Good afternoon, everybody, and welcome to the Hydrogen Fuel Cells Europe here at the Hannover Messe 2023. We're here at the technical forum where we dive into all of the juicy technical details. Please have a seat, have a drink, and join us for the next talk. We'll be talking about hydrogen fuel line requirements for hydrogen-powered vehicles. Please welcome to the stage Veritas Teammanager Materials, Mr. Sergio Pascuzzi. Welcome.
Hello. So, hello. Thank you very much for your interest. I have the honor to keep you a little bit from your lunch. So I will tell you a little bit about the fuel line or the requirements on fuel lines for hydrogen-powered vehicles. We are, since 1999, doing hydrogen for the German or for the car industry. We started with General Motors in 1999, which goes up to, in 2018, a big German car manufacturer contacted us. Could you imagine to develop and construct a fuel line for high pressure? Because we before did only fuel lines for low pressure anode lines. And we said, yes, that's a possibility. We could do this. And before developing, we had to face the requirements. The temperatures are going from minus 60 degrees to 85 degrees. The steel lines for the high pressure lines have to be robust against hydrogen embrittlement. The pressure, as I said, is 700 bar, 17 megapascal. The connection itself has to be leak tight. And you have, since it's a car, the typical vehicle stresses like vibration, like crash loads or whatever, chemical stresses. So we faced the tasks and said, we are doing common rail lines since 2006, and we had over 40 million lines produced without any errors. So why don't we take the ISO 2974 standard for the hydrogen lines as well? This is a known standard in the automotive industry, and we have only good experiences with it. But we had to change a little bit. Since it is hydrogen, we took an stainless steel, and due to the demand to being at low temperature as well, to be valid or to be safe at low temperatures, we had a steel with more than 30% nickel, which keeps the ductility high at the low temperatures. And then we contacted our manufacturer that he took a special annealing process for these fuel lines, and we have a patented process to get an error-free surface of these high-pressure fuel lines. So what you can see here, since this is sorry that the laser doesn't work here, since we have here a cone geometry, we have here a ball and cone geometry, we are able to compensate angular tolerances or deviation in angular alignment without loosening with having the leakage low. The pieces can be reassembled 25 times, and we have on this ISO 2974 standard, we have 50 years of experience. As I said before, I think we manufactured more than 40 million lines. So the annealing of the stainless steel gives the stainless steel a finer grain size in the steel. When you see here, sorry that does not work. Here without the annealing, without the special annealing, we have a very coarse, a very bumpy surface, and this is not good for keeping the leakage low or being leak tight against hydrogen. So we have here with this special annealing process, we have a more smooth surface, and this gives us a high resistance against leakage. So we are really leak tight with this, or more leak tighter with this than with a normal manufacturing. And as you can see here in the front, you have here no errors of the tube outside. We have a special manufacturing process which kind of creates a new surface on the sealing area. So we have from bumps or scratches or whatever it is on the outside of the tube, we smooth the surface, so we have every time an error-free surface on this end where the sealing happens. So then I go to the medium pressure lines where we have a little bit lower pressures from up to 60 bar, 6 megapascal for burst pressure. We have temperatures, and this does not right now this does not face the actual task, because now we have to go from -50 to 130 degrees Celsius. This is the newest task from our customer. It has to be resistant against hydrogen. It has to be leak tight against hydrogen. Since we have a flexible part with it, we have to have lowest ion leaching, because the ions are the fuel cell does not like the ions. It will end in getting a lower lifetime. And since we are on a car, we have to withstand the test with pressure pulses and dynamic bending. And a typical vehicle stresses, like I mentioned before, ozone, oxygen, temperature, chemical. We came with the development from our CNG liner, the G liner, which is ECE R110 certified, which goes up to 30 bar and goes from -40 to 120 degree and has a barrier layer against methane. But we changed the barrier layer, and we changed a little bit the formulation of the rubber, got a little bit the temperature down to -50 degrees. On the outside, we use an epichlorohydrin rubber, which is known for relative low permeation rate against hydrogen or against gases. We have a very good mineralic oil resistance. We have a good acid or alkalic resistance, and high temperature resistance up to 150 degree. So this could be good for the higher temperature I mentioned just. And then, as I said before, we optimize it for the low temperature. The TG is about -60, -65 degree. The inner layer is made from FTPV. What is FTPV? The FTPV is a thermoplastic matrix, a Fluor thermoplastic matrix, and we have here vulcanized domains inside. And the size of this vulcanized domains of this FKM is about 1/3 of a micron. So it's very smooth. It's very fine grained. And this gives us a good mechanical behavior as well as a good chemical behavior as a permeation barrier against hydrogen. There are some results of our ion leaching test, and as you can see, this here is the FTPV. On this side, we have the blind probe. Most of the ions, except of silicium, most of the ions are not really can be found in the solution. So I think it's nearly inert. It's chemically inert, so we have no problems with our fuel cell. The permeation. This is a result measured by an OEM, and we have here on the left side we have the butyl caoutchouc, and on the right side we have here our flex liner, and we see that the permeation, the hydrogen permeation through the wall of the flexible fuel line is much lower than at the permeation at the butyl caoutchouc. The FTPV inside, you can see the inside here of the flexible fuel line. The dynamic behavior is very good because of this very fine structure of this 1/3 micron domains of FKM, which is tested in the Demattia flag test, where you have a probe which is bended up and down. I think it's 200,000 bendings at 135 to 150 degrees, and with a kink rate of 110 per minute. And then after 200 cycles, we had no cracks inside of the tube. And we made a similar test in the certification procedure of our fuel oils, of our flexible fuel lines, where we have 50,000 pressure pulses at minus 40 degree and 50,000 pressure pulses at 85 degree with 6,000 superimposed bendings. So you have here inside, you have the pressure pulses, and this part of the flexible fuel lines will move plus minus 15 millimeters. And this at minus 40 degree up to 85 degree. And we analyzed the probes after the test. We passed the test, we successfully passed the test, we analyzed the probes after the test, and we had no cracks, we had no leakage at our certification examination. And so we said, yeah, that's it. We are fine with it. We can deliver it to the customer. And I'm glad to say that these solutions, the hardware, the high pressure and the medium pressure solution is driving on the street at a German car manufacturer's hydrogen fuel cell car. So, thank you very much.
Thank you, Sergio, for your very interesting presentation. Are there any questions from the audience at the moment? I see a gentleman over here.
You talked about leakage side. What is the leakage rate, or just to
Can I say it in English? Can I say it in German? 1 mal 10 hoch minus 4 Millibar Liter pro Sekunde. 1 mal 10 hoch minus 4 Millibar Liter pro Sekunde ist die gesetzliche Vorgabe. Wir liegen etwa 2 Größenordnungen drunter. Also wir sind bei 0,3 Normkubikzenter. The question was the leakage rate, and the answer is we are 2 decades below the regulations. The regulatory regulation is 10 norm cubic centimeters per hour, and we are around 0.3. Yep.
All right, sounds very good. I see another question over here.
Thank you very much. The length of the lines, there's no point.
Everything between 20 centimeters and 2.5 meters, no problem. So you can go from the tank to the fuel cell with a line, no problem. Yeah.
Any other questions in the audience at the moment? Then maybe I have one more question. So if we want to see these fuel lines in person, can we see them at your stand?
Yes, you can visit us here in this hall 13 at the booth C36. Over there, the Hessen booth over there where you can see the Hessen sign. Yeah?
Perfect. So C36.
C36.
I invite you all to get your hands on some nice fuel lines.
Yeah.
Thank you very much, Sergio.
Thank you very much. Bye-bye.